they're very, very different. The adage is that which proves too much proves nothing. Here we see the reptile and the fish and the mammal that look similar, that are not related at all, we're told. And when we look to the marsupial animals, we see anteaters, we see mice, we see moles, we see wolves, we see cats, but none of them are kin. Very different, totally different reproductive system. But I thought similarity was supposed to prove common genetic relationship. No, it does not, especially when we examine the genetics and when we see similarities that obviously do not. David Norman, Sedgwick Museum, University of Cambridge, says from very different stocks, the marsupial carnivores and placentia carnivores produce animals almost identical in physical form. The true wolf, the thylacine marsupial wolf, almost identical. We look at the saber-toothed tigers, one marsupial, one placentia. Not kin, but almost identical. The wolf skulls, you have to be a real expert to see the difference. Well, you see, similarities don't always prove the point. And then, if they did, then this creature, the platypus, would be kin to everybody, wouldn't he? He has fur like the beaver. He has fangs that inject venom like the reptile, lays eggs like a reptile, has feet like a duck, and a bill like a duck. In fact, when they were first discovered, they were written up in Nature magazine as a fraud. Somebody, they said, sewed a duck bill on a beaver, which is what it looked like. Well, he's kin to everybody. We see the fangs here, and we see the injecting venom like the reptiles, but he's not. And he's not a duck. And so that which proves too much proves nothing. Let's look at the overall picture of similarities. When we look at blood serum, we're often told the chimpanzee blood serum is very similar, and with the right anti-serum, actually you can use chimpanzee blood serum with humans, with some of them. When you can't use your own brother sometimes with a different blood type. That's very, very similar. And we look in the mirror, and I won't get personal, but some of you can see some real similarities there, and so it's not unexpected in the serum. But let's look at the whole picture and see if we're looking at a branching pattern or a mosaic pattern. When we look at milk chemistry, it's not the chimpanzee at all. It's the donkey that's our closest relative. When we look at cholesterol, which everybody seems to be concerned about today, it's the garter snake that has cholesterol just like we do. When we look at foot structure, which we're concerned about down at Glen Rose, what could have made this? Well, the closest relative seems to be a glacial bear. Of course, he's a quadruped with big claws. You can distinguish that, but you remove the claws, and wow, it looks very human. Certainly the skeletal structure. It's the reverse image. The thumbs are on the outside. You can tell the difference, but it's very, very similar, I think, due to common designer. The chicken has a very complex enzyme, lysosome, designed, I think, to fight bacteria in the egg. Well, we need that kind of thing in our eyes, and the tear ducts produce that to fight bacteria. Here's where the blue tile, if you please, was needed with the egg and with the eye. We need bacteria-fighting enzymes, and it's a very, very complex protein involved here. Not only a long lineup of amino acids, but folded geometrically in a very complex manner in order to function appropriately. When we look to blood antigen A, the butterbean has blood antigen A just like we do, and lo and behold, the cockroach has this very complex brain hormone, just as we do. Notice this picture from Discovery magazine of just a few years ago. Under the picture it says, "Don't squash that roach, he may be your cousin." He says the cockroach and man, it seems, share a common brain hormone. Not similar, but a common brain hormone. We're looking at similarities, but they're not branching. They are of a mosaic pattern that would indicate a common designer. They are not from common genetics, from the same part of the embryo. They're different. They fit our view of the evidence. They don't fit the evolutionary view. When you're allowed to choose which things you want to show, not the whole picture, and then line them up the way you want to line them up, like they did with the chromosomes, you can prove just anything you want. This cartoon was published back in Darwin's day, pointing out that some might try to begin with a pig. Some fellows are kind of pig-headed. And you change that pig there on the left-hand side upward just a little bit at a time. Gradually, you can get it up to look like a bull. and then continue to change that bull on down around to the right, and you come up with a man. And so obviously man evolved from pigs by means of the bull. Isn't that scientific? That's what happens when you see people selectively picking out the evidence and eliminating evidence that doesn't fit and arranging it the way they want to. And when you look at the fossil evidence, you see people selecting in their lineups what they want, eliminating the whole picture, which I want you to see, and then arranging them the way they want to depict their picture. But when you look at the whole evidence, all of the evidence from similarities, you see a distinct advantage with the creation model, as we will see throughout our examination of the evidence as we compare the two models. We have seen that the critical evidence of the fossil record, certainly in the beginning, is in favor of the creation model when we see sudden, complex beginning without that progressive continuum the evolutionist would predict. When we look at the similarities, which are supposed to guide these family trees, we see the similarities actually are selected similarities, ignoring many similarities, and that they are arranged according to arbitrary assumptions and actually can best be explained not by common genetics, but by common designer. But if we're to see change in the fossil, if we're to see evolution, if it's to be proved, how would you discern it from the fossil record? Well, you'd have to see these continuums, these changes from one kind to another kind. Is that what we see? Well, let's talk about that portion of it, and again allow the evolutionists themselves to describe the evidence. Notice the statement by Stephen Gould, who says, every paleontologist knows, in other words, this is not just a few willing to admit it, they all know most species don't change. That's bothersome. It brings distress. Now, as we saw from Dawkins earlier, the fossil record was delightful to the creationist in his analysis, but now then, in terms of trying to find change, it's distressful and it's bothersome to the evolutionist because you don't see the change in the fossil record. He says they may get a little bigger or bumpier, they may remain, but they remain the same species, and that's not due to imperfections and gaps, but stasis. Darwin said the imperfection of the fossil record, the fact we haven't collected enough, is why you have the gaps. But he says that's not the case. Now then, we have collected billions and billions of these things. The principle that we see is stasis. It stays the same. It doesn't change. Now, stasis is just about the opposite, almost precisely the opposite of evolution. And that's the principle that dominates the fossil record, according to perhaps the best known and leading evolutionist, anti-creationist in the country today. He continues to say, yet this remarkable stasis has generally been ignored as no data. If they don't change, it's not evolution, so you don't talk about it. Now, this is not a creationist, though it may sound like it, but the leading anti-creationist, evolutionist in the country. He said, I regard the failure to find a clear vector of progress. Now, how would you prove evolution? Well, you'd have to show some progress in the fossil record. The failure to find a clear vector of progress in life history is the most puzzling fact of the fossil record. Now, on the one hand, for the creationist, we see that which is delightful. It delights us. On the other hand, it's bothersome, it's troubling, it's puzzling. What's the problem? He says, we have sought to impose a pattern that we hope to find on a world that does not really display it. This puzzles him. He's had a failure in the kind of evidence that you really need to prove evolution, and it's just not there. And that's not me saying that. That's the leading authority in the field saying that. Notice the statement from Natural History again. He says, we can tell tales of improvement for some groups, but in honest moments we must admit that the history of complex life is more a story of multifarious variation about a set of basic designs than a saga of accumulating excellence. Here we caught him with that word design again, which he doesn't believe in. Stocks, the marsupial carnivores and placentia carnivores produced animals almost identical in physical form. The true wolf, the thylacine marsupial wolf, almost identical. We look at the saber-toothed tigers, one marsupial. It was supposed to prove common genetic relationship. No, it does not, especially when we examine the genetics and when we see similarities that obviously do not. David Norman, Sedgwick Museum, University of Cambridge, says from very different one placentia, not kin, but almost identical. The wolf skulls, you have to be a real expert to see the difference. Well, you see, similarities don't always prove the point. And then we see anteaters, we see mice, we see moles, we see wolves, we see cats, but none of them are kin. Very different, totally different reproductive system. But I thought similarity, they're very, very different. The adage is that which proves too much proves nothing. Here we see the reptile and the fish and the mammal that look similar, that are not related at all, we're told. And when we look to the marsupial animals,